Okay, this is number 18 on our Calculus 1 differentiation in class practice. And we're starting to do trig derivatives. And I wanted to make sure that we practice some. This is the same pages that your homework is, except that I assigned the odds because you have the answers. So I thought we could do some practice together. And make sure you have your derivative card out with you because I know you're just starting to do this to make sure that you know what your derivatives are. Okay? So if I look at the very first one here, I have y equals 2 cosecant x plus 5 cosine x. So I look at it and say, well, I have a trig function here and a trig function here. I'm good. I can start doing the derivative right off the bat. So I'm going to say y prime. And I know the derivative of cosecant it's a cofunction, so I know it's negative. And I know it's negative cosecant cotan of x. So what I'm going to do is just put the negative right in front of the two right off the bat. It's going to be negative 2 cosecant x and cotan x. So that is the derivative of our first term. Our second one is 5 cosine x, and I know the derivative is a cofunction, so I know it's negative, so I might as well make it negative. It's going to be 5, negative 5 sine x. Then I look and see if I can factor anything, and I can't, so that's how I do that derivative. So they all don't start this. I mean, it starts out easy, but I know that it gets more difficult as we go along. Okay, so I look at number 4. Whoops, number 4, and I see that number 4 is a product. Now remember, using the product rule is not a derivative, it's a method to actually do the derivative of a product of two different functions. So my f function is a power function and my g function is a trig function. So I'm going to set up my f and g's. So I have my f to be radical x, or we can say it's x to the 1/2. F prime is going to be 1/2 x to the negative 1/2. G is sine x, and the derivative of sine x is g prime is cosine x. So I always set up my f and g's. Remember the product rule is y prime is going to be f prime g plus f g prime. So basically I kind of calling it plugging and chugging. Once you set up your f and g's here, which is fun to say, we can come over here and start doing our derivative. So I have f prime of x is going to be f prime g, so we'll write it this way, 1/2 x to the negative 1/2 times sine x, plus f g prime. I'm going to use x to the 1/2, because when I do it this way, it's so much easier to factor. So here I have a term here, Christmas colors, and a term here. And I'm actually going to pull out the 1/2 as well. So I'm going to factor out a 1/2. Out of the x terms, the smallest one is x to the negative 1/2. So I'm going to factor that out. When I do, this divides to make a 1, this divides to make a 1. So in my first term, I just have a sine x left. Okay. On my second term, it's a little trickier because I factor out a 1/2. Remember, there's a 1 here. 1 divided by 1/2 is the same as saying 1 times 2. So that's going to be 2. X to the 1/2 divided by x to the negative 1/2. They have the same base. So I'm going to subtract my exponents. A half plus a half is 1. So it's x to the first power and cosine of x. And I left it in factored form. You could rewrite it and bring this down, but this is in perfect form for us if we had to use it to solve for anything. All right, 6. I have another here, product rule. This is my f and this is my g. I see my f as an exponential function now, and my g has a trig function and a power function. So we've got a lot of stuff going on here. So let's set up our f and g's. So our f is going to be e to the theta. F prime is e to the theta. G is going to be tan theta minus theta. G prime is, well, the derivative of tan theta is secant squared theta. And the derivative of theta is like an x, it's a variable, is just minus 1. Okay? Now, the one thing on here, you have to be careful because this really, right here, I start looking at anything with a squared there, that's an identity. And basically, I know that that equals tangent squared because I know one of my identities. This is tangent squared x. And we just ended up going through the identities on our packet. So what we did was we went through what all the identities could be, and I showed you how it came about. And one of the identities, and I'm going to show you here, is tangent squared theta. I'll tell you where that came from. Plus 1 equals secant squared theta. So that was one of our Pythagorean trig identities. And I look at it and I say, well, this is secant squared theta minus 1. So if I move this over to this other side and subtract 1, I get tangent squared theta actually equals, let's make that a little bit nicer here. Tangent squared theta equals secant squared theta minus 1. Because of that identity, I can now say this is tangent squared. So you have to kind of be on the outlook for those identities. And now I'm going to start doing the derivative. So using trig functions does give you another level of making sure you know your identities, and sometimes it can simplify what you're doing. So for 6, I'm going to do g prime of theta because that's what we got here. Is going to be f prime g, so it's going to be e to the theta times tan theta minus theta plus fg prime, that's a plus, e to the theta, and it's going to be tan squared theta. Now remember, this is a term here and this is a term here. And I can take out an e to the theta, so I will. So g prime of theta is e to the theta, and then it's going to be tan theta minus theta will be left in that first term plus tan squared theta. And then I just kind of rewrote that because it looks weird to me having the tan squared at the end. So I've got g prime of theta equals e to the theta times tan squared theta plus tan theta minus theta. So that would be how we would leave number 6. Now let's do 8. Now 8 I can look at and I can see I have a trig function here and I have a exponential function here, and I also see that it's a quotient. So I'm going to use this one is the quotient rule. So I've been using the product rule. I've been using the product rule a couple times. So we're going to do the quotient rule. So let's set up our f and g's. Our f is cotan theta, cotan t, excuse me. And remember, what I told you about that is if it's a co-function, I know my derivative is negative. So f prime is going to be negative cosecant squared t. G is e to the t. G prime is e to the t. I so love that derivative. And let's go through this. Remember, we're going to use the quotient rule. So the quotient rule is y prime is f prime g minus f g prime all over g squared. Okay, so I'm going to use that and kind of plug in everything we have here. So I have f prime of t is f prime g. So I'm going to stick the negative in front, negative e to the t cosecant squared t minus f g prime. So I got minus, I'm just going to put the e to the t in front, cotan t, which looks weird because you could put that in parentheses if you want, all over e to the t and it's squared. A couple things that people are a little concerned with. This really, you could write it as e to the 2t. And I will eventually sometime, but not in this video, but because I'm going to try, I see this term here has an e to the t in it, and this one has an e to the t in it. I'm going to try to factor out and get it down to a power of 1 anyway. So I'm just going to leave it the way it is because I think you'll see it better. So I'm going to do f prime of t. And I'm going to factor out the e to the t so I can simplify this more. So I've got a negative cosecant squared t minus cotan t all over e to the t squared. And now you see why I did this, because I can say thanks for playing, that cancels out. So now I just have one e to the t in the bottom. So this comes out to be negative cosecant squared t minus cotan t all over e to the t. So that's how I'm going to leave that derivative. Okay? This derivative right here, number 10, I see it's also the quotient rule because it's a quotient, and I see they're both two trig derivatives. So let's set up our f and g's and get all organized. So this is f and g. So f is 1 plus sine of x. F prime is just going to be cosine x because if I take the derivative of 1, it's a 0, and the derivative of sine is cosine. Then g is x plus cosine of x. G prime is going to be the derivative of x is 1. The derivative of cosine is negative sine of x. So we're going to use the quotient rule again, and which we just did previously. So I'm going to start plugging it in. So I've got y prime is f prime g. So I have cosine x times x plus cosine x minus f g prime. So I'm going to write it as 1 plus sine x times 1 minus sine x. And some of you might know that's the difference of two squares, so I can rewrite that in a minute. But we're going to take baby steps and do a little bit at a time. All over g squared, so it's going to be x plus cosine of x squared. And don't multiply the bottom out. So I'm actually going to take and do the distributive property here. I'm going to distribute here and here, and then I'm also going to multiply that out. So I have y prime is x, whoops, what did I do wrong here? Hang on a second. This should be cosine of x. I'm so sorry. I get going so fast. Right here, I apologize. This should be cosine of x times that. So when I do the distributive property, see, I catch myself when I get going like that. It's going to be x times the cosine of x. So I'm just going to like throw it in the front. It's not cosine x squared plus this one's cosine squared x. Now remember what I told you. This is cosine x times cosine x. It really is this cosine x squared, but we can write it like this with a 2 right here. So I just wanted you to see that. Minus, and I'm going to go really slow here because I want you to see what I'm doing. These two multiplied out, that if I multiplied 1 times 1 minus sine x plus sine x and then minus sine squared, this is 1 minus sine squared, which is the same thing as the difference of two, that's the difference of two perfect squares. That's really what that is. All over x plus cosine of x squared. Now, as soon as I see a squared like this and a 1 going on here, I'm thinking, uh-oh, I bet you this is an identity. So let's look down the identities we know. There's 3 of them that I did in class. So I know that sine squared x plus cosine squared x equals 1. And this is 1 minus sine squared, so I'm going to move this over here. If I did, that would be cosine squared x equals 1 minus sine squared x. So I can actually replace this whole thing right here with cosine squared x because that's what it equals. And I just wanted you to see that. It makes it so much nicer and simplifies this. So I've got here y prime equals x cosine of x plus cosine squared of x minus cosine squared of x, because that's what it just did, all over x plus cosine of x squared. Then I can say thanks for playing. That's always nice. So the derivative is x cosine of x all over x plus cosine of x squared. So I know there's 2 more problems, but I'm going to stop this video now because I get kind of long, and then I will do another one to try to chunk this up.